Hello, today we learn about the moles concept, specifically the relationship between the moles and the number of particles. So for that, we need to understand what exactly the mole is. Now, when we are asked to calculate the amount of substance, so we calculate that amount of substance in moles. So mole is actually the measurement unit for the amount of substance. Now, how 1 dozen is always equal to 12 in number. It doesn't matter how big or small the size of the substance is. It just means that a dozen is equal to 12. A dozen eggs means the number of eggs are 12. A dozen pencils means the number of pencils are 12. Or a dozen donuts means there are 12 donuts. Similarly, 1 mole of a substance always has a fixed number of particles. So those particles are 6.022 times 10 to the power 23. And because this number does not change, so we call this number as Avogadro's constant, and it is represented by Na. Which means, to make it clear, we can write that 1 mole of sodium will have 6.022 times 10 to the power 23 particles. 1 mole of methane will have the same number of particles. And 1 mole of sodium chloride also will have the same number of particles. So irrespective of the type of substance which has been given to us, 1 mole of a substance always has the fixed number of particles. The number of particles do not change. The number of particles, though, they're always the same, but the type of particles could change from substance to substance. So if we have been given a substance which is neither in ionic bond nor in covalent bond, so the examples could be copper, sodium, or helium. These are the elements in their atomic state. So the particles we'll be talking about for them will be the number of atoms. But if the substance is a covalently bonded substance, the example could be hydrogen. So in hydrogen, we have 2 hydrogen atoms, both of them being non-metal, so covalent bond, but the atoms are same. In HCl, we have a hydrogen which is bonded to chlorine, so a non-metal and a non-metal, so again the same. So if we have been given any substance in which the atoms are covalently bonded, then those particles are referred to as molecules. And in case of the substance being given to us is ionically bonded, in this case we can take the example of NaCl. Na is a metal and Cl is a non-metal. So metal and a non-metal in ionic bond formation. The same is the case with AlF3 and CaO. So a metal and a non-metal, and here also calcium being a metal and oxygen being a non-metal. In this case, the particles being referred to will be the formula units. Now, because 1 mole has the same number of particles, so 1 mole of sodium, because it is an atomic state, so the number of particles will be atoms. Methane, because it is a covalently bonded compound, so the particles are molecules. And NaCl, because it is an ionic bond formation, so the particles are formula units. Now, using this triangle, we can write the relationship between the number of particles, the moles, and the Avogadro's constant. So the number of particles is equal to the moles multiplied by Avogadro's constant. So here is the relationship, and if we rearrange it to find the number of moles, it will be number of particles divided by Avogadro's constant. So this is the same relationship written in another way. Let us try out a question. So it says, how many atoms are present in 0.5 moles of copper? Now, from the relationship, we know that the number of particles can be calculated by taking the moles which have been provided to us and by multiplying it by the Avogadro's constant. But because the substance given to us is an element, neither in ionic nor in covalent bond, hence the particles we'll calculate from this formula or using this relationship are going to be atoms. Which means we'll take the number of moles, 0.5, and multiply it by the Avogadro's constant, which is 6.022 times 10 to the power of 23. And now if we multiply these two numbers, we'll get 3.011 times 10 to the power of 23. And these particles, just because it's copper, we have those many number of atoms present. Let us look at another question which is not that straightforward. So this says that you have to find the number of atoms in, again, 0.5 moles, but now the substance given to us is glucose. The relationship is the same. If we have to find the number of particles, we have to take the number of moles and multiply it by the Avogadro's constant. But the thing to keep in mind is that because it's glucose and we have three nonmetals, carbon, hydrogen, and oxygen bonded to one another by a covalent bond formation, hence the particles which we are going to find using this relationship are going to be molecules. So we'll take 0.5, which is the number of moles, and multiply it by Avogadro's constant to give us 3.011 times 10 to the power 23 molecules. We have figured out the number of molecules, but the question does not ask for the number of molecules. It is asking for the number of atoms. Now, we're going to write the formula of glucose over here. So we have C6H12O6. So we'll find the total number of atoms in one molecule of glucose. So one molecule of glucose has 6 carbon atoms plus 12 hydrogen atoms plus 6 oxygen atoms. So the total number of atoms are 24. Which means now we have 3.011 times 10 to the power 23 molecules. And just because one molecule has 24 atoms, so we'll take these number of molecules, 3.011 times 10 to the power 23 molecules, and multiplied by the total number of atoms, which is 24, to get the total number of atoms. So this is equal to 7.226 multiplied by 10 to the power of 24 atoms. So we can clearly see that if the substance is in covalent bonding, so if we take the number of moles and multiply by the Avogadro's constant, we do not directly get the atoms. We get the molecules, and then those molecules need to be multiplied by the total number of atoms present in the molecule to give us the required number of atoms. Now, if the question was asking for the number of carbon atoms in the same moles of glucose, then we already have the total number of molecules, but now we can see that one molecule has only 6 carbon atoms. So what would we do is, to find the number of carbon atoms, we would take 3.011 times 10 to the power of 23 and multiply it by the number of carbon atoms, which is 6, to give us 1.807 times 10 to the power of 24 carbon atoms. And if we were being asked to calculate the number of hydrogen atoms, then the same number, the number of molecules, should have been multiplied by 12 to get the number of hydrogen atoms. So it depends upon which atoms we are being asked to calculate in the question. Let us look into another question. It says, how many moles are there in these many atoms of carbon dioxide? We know already the relationship between the moles and the particles and the Avogadro's constant. So we know that to find out the number of moles, we just have to take the particles and then divide it by the Avogadro's constant. So this is the relationship. We already know the value of Avogadro's constant. The only thing we need to know is or write down is the number of particles. But because it is carbon dioxide, which is a covalent compound, so the particles we need to put down over here are molecules. But we haven't been given the molecules. We have been given the number of atoms. Now, one thing to keep in mind again is that when we write carbon dioxide, one molecule has got a total of 3 atoms. So, one atom is 1/3 of a molecule. Which means to find the molecules, we just have to take the number of atoms and divide by 3. So, number of molecules of carbon dioxide will be equal to the total number of given atoms, which is 1.5 times 10 to the power of 25 and divided by a 3. This gives us 5 times 10 to the power of 24 molecules. And once we have the molecules, so substitute the molecules over here and divide by the Avogadro's constant to give us the number of moles. So here we have taken the number of molecules and divided by the Avogadro's constant to give us the number of moles, which is 8.30 moles. This means 1.5 times 10 to the power 25 atoms of carbon dioxide will be having 8.30 moles of carbon dioxide. Hope you understood the concept and enjoyed the video. See you in the next one. Bye-bye.